All right, welcome to The Explainer. Today, we're diving into something really interesting, that fragile line between a secure system and a total disaster. And you know where it all begins? Right inside the human mind. We're going to get into why brilliant people build vulnerable things, and more importantly, how we can stop it.
So let's just jump right into the big question. What's the deal here? It's not because these engineers aren't smart enough. Not at all. It's something much deeper, a quirk in how all of our brains are wired that creates these huge blind spots, especially when you're dealing with the unforgiving world of cryptography. To really get this, we gotta borrow a powerful idea from Daniel Kahneman. He figured out that we basically have two modes of thinking. There's the fast mind, or system one. That's your gut, your intuition. It's automatic. Then there's the slow mind, system two. That's the deliberate, analytical part that you have to consciously switch on. Think of it like this. Your fast mind drives you home on a familiar road, but your slow mind has to kick in to solve a tough puzzle. Now, that fast mind is an absolute wizard at taking shortcuts. It's what helps us get through the day. But here's the catch. In the super precise, zero mistakes allowed world of cryptography, those mental shortcuts, they're basically traps, just waiting to spring. And one of the biggest, most dangerous traps of all is the overconfidence bias. This is that little voice in your head that whispers, "Yeah, I got this. This solution looks good. It's clever. It's gonna work." We just naturally trust our own snap judgments way more than we should. And get this isn't just about us regular folks. Even the absolute top experts fall for it. This piece of data is just stunning. It shows that doctors who were 100% certain about a diagnosis were actually wrong 40% of the time. A shocking number. Now, if it can happen to them, you can bet it happens to a software developer trying to hit a deadline. So, okay, this isn't just some abstract psychology idea, right? This has real, and I mean disastrous consequences when people sit down to write code. Overconfidence makes us grab for the easy, familiar solution, the one that feels right, without ever stopping to engage that slow, analytical mind to actually check if it's safe. And this table just nails the problem perfectly. The fast mind of a programmer sees a task and immediately reaches for something simple and familiar like strcpy. It's easy, you know it gets the job done. But the slow mind hits the brakes. It knows about the massive danger of buffer overflows, where an attacker can cram too much data into a space and take over your program. So it deliberately chooses the safer, slightly more complicated option like strcny. It's a tiny bit more work, but it makes a world of difference for security. And this pattern, this choice of easy over safe, is why we see a whole catalog of classic cryptographic blunders. You know, things like misusing initialization vectors, which can totally wreck your encryption, or trying to invent your own hashing function because it seems simpler than using a standard one, or trusting user input, or my favorite, security by obscurity. They're all the same mental shortcut, the same trap. Okay, so we've seen how our own brains can trick us. But now, let's flip the script and think about the attacker. Because while designers are often running on that fast, intuitive mind, the people trying to break their stuff are doing the exact opposite. They are slow, they are methodical, and they only need to find the one single shortcut you took. I mean, look at Kevin Mitnick, one of the most famous hackers ever. His entire career was basically built on this one simple truth. He knew the weakest link isn't the fancy tech, it's us. It's the predictable, trusting, and usually rushed nature of the human mind that attackers love to exploit. And they absolutely have a playbook. Frameworks like this one, the Cider-Kill chain, show you that a successful attack is almost never a lucky guess. No, it's a formal, step-by-step process. It's a project plan for breaking your system, powered entirely by slow, deliberate thinking. So here's the big shift in thinking we need to make. To build secure things, you have to learn to think like the bad guy. You have to turn that same slow, methodical, skeptical mind back onto your own work and hunt for the weaknesses that your own fast-thinking habits created. Okay, so if we can't always trust our gut instincts, what do we do? How in the world do we build systems that protect us from ourselves? The answer isn't just try harder. It's about changing the environment itself. Well, the authors of the incredible book, Nudge, figured it out. They found that the best way to get people to make better choices isn't with rules or punishments. It's to use what they call their magic elixir. Just make the right choice the easiest choice. And this idea has a name in the world of software, choice architecture. It means we can actually design our development tools and our processes to gently push engineers toward doing the secure thing, making it the path of least resistance. So, what's that look like in the real world? Well, it means giving developers libraries that are secure by default, so their fast choice is actually the safe one. It means making it super easy to use well-vetted, peer-reviewed algorithms and strong message authentication codes, which are like a secret tamper-proof seal on your data. It's about automating security scans, so people don't even have to remember to run them. The whole game is making the easy way the secure way. But look, at the end of the day, tools and clever nudges can only take you so far. They're there to support the real goal, which is a fundamental shift in how we think. The biggest change has to happen right up here, in the designer's mind. And what is that mindset? It really boils down to one simple rule: embrace simplicity. You have to fight complexity with everything you've got. Why? Because the moment a system gets too complex to understand, it becomes absolutely impossible to secure. Your fast mind can't grasp it, and your slow mind is guaranteed to miss something important. And this slide really gets to the heart of that mindset shift. The fast brain loves security by obscurity. It's that tempting, overconfident idea that if you invent your own secret solution, no one will ever be smart enough to break it. A truly secure mindset does the exact opposite. It trusts open, public, peer-reviewed systems that have survived the slow, deliberate attacks of thousands of experts. It assumes there are flaws and trusts the process that finds and fixes them. So what's the bottom line here? It's this: security is never an accident. It never just happens. As you can see here, it's the result of a deliberate, disciplined, and often counterintuitive process. It's about consciously choosing to engage that slow, analytical part of your brain, even when your fast brain is screaming at you to just take the easy shortcut. So as we're all out there building our digital world, the most important question we can ask isn't about the newest technology or the fanciest algorithm. It's about us. It's about which part of the human mind, the fast and easy or the slow and deliberate, we're choosing to put in control.